Welcome to Regents Chemistry Review. Here at the Phoenix Learning Center, I'm Mr. B. During this lesson, I will explain how to use the Solubility Reference Table, Reference Table G. When salts dissolve in water, the interaction between the positive and negative ions from the salt and the polar water molecules are called molecule-ion attractions. A plot of temperature versus the solubility of a substance is called a solubility curve. This is an image of the solubility curve for the compound potassium nitrate, KNO3. According to the curve, at 100 degrees Celsius, approximately 250 grams of the salt should dissolve in 100 mLs of water. This amount of salt will form what is called a saturated solution. A saturated solution contains the maximum amount of salt that can dissolve at a certain temperature. However, if only 100 grams of KNO3 is dissolved, the solution is not called a saturated solution. It is now called an unsaturated solution. An unsaturated solution will contain less than the maximum amount of salt that can dissolve at a certain temperature. For an unsaturated solution, the point on the graph will always be written below the saturation line for obvious reasons. When a saturated solution has been slowly cooled such that the dissolved salt remains in solution above the amount of a given temperature, the resulting solution is called a supersaturated solution. In this example, if 300 grams of KNO3 is dissolved at 110 degrees Celsius to form a saturated solution, and then slowly cooled to 100 degrees Celsius, the original 300 grams may remain suspended at 100 degrees Celsius, creating a supersaturated solution, although according to the graph, only 250 grams of this salt should be dissolved. The point for a supersaturated solution is always written above the saturation curve. Now using reference table G. Reference table G consists of solubility curves for a variety of ionic and covalent compounds. Table G indicates how many grams of a substance will dissolve in 100 mLs of water at a certain temperature. Table G consists of ascending lines and descending lines. The ascending lines represent ionic compounds, and the descending lines represent gases. The y-axis is labeled solubility, grams of solute per 100 grams of water or 100 mLs of water, and the x-axis is labeled temperature. It is clear from table G that as the temperature increases, the solubility of a salt will also increase, and as the temperature increases, the solubility of gases will decrease. Consider the following example. How many grams of sodium nitrate will dissolve in 100 grams of water at 50 degrees Celsius to produce a saturated solution? First, go to 50 degrees Celsius on the x-axis and draw a line to intersect the NaNO3 solubility curve. Now draw a line from the point of intersection to the y-axis, and the line intercepts the y-axis at 115 grams. So 115 grams of the compound will dissolve in 100 grams of water at 50 degrees. Consider the next example. Suppose only 50 grams of sodium nitrate is dissolved in 100 grams of water at 50 degrees. How many additional grams of sodium nitrate should be dissolved to produce a saturated solution? From the previous example, we know that 115 grams of the compound will dissolve in 100 grams of water at 50 degrees. So simply subtract 50 grams from 115 grams to determine the additional amount required, and the additional amount will be 65 additional grams. Now suppose 67 grams of ammonium chloride, NH4Cl, is dissolved in 100 grams of water at 80 degrees Celsius. How many grams of precipitate should form if the solution is now cooled to 30 degrees Celsius? A precipitate is a solid that forms from an insoluble compound. When the dissolved substances exceed their saturation point, they will form crystals that will fall out of solution as a precipitate. At 80 degrees Celsius, 67 grams of NH4Cl will dissolve. At 30 degrees Celsius, 42 grams of the salt will dissolve. The difference will represent the precipitate, which should be approximately 25 grams. Now for the effect of increasing volume. Consider this example. If 35 grams of potassium iodide, Ki, dissolves in 100 mL of water at 10 degrees to form a saturated solution, how many grams of Ki should dissolve in 200 grams of water at the same temperature? In this particular case, we have double the volume of water, and doubling the volume of water doubles the amount of salt that can dissolve. Therefore, in 200 grams of water, 270 grams of Ki will dissolve to form a saturated solution. Okay, this concludes my explanation of how to use the solubility table, reference table G. Hopefully this video has been helpful. And remember, should you need more assistance, you're free to visit my Facebook page at facebook.com/WPHS Chemistry. Thanks for watching, and hey, good luck on your upcoming examination. Take care.